The next type of stream that I'd like to talk about then, that's part of the IO API, is buffered input stream. So a quick overview for this presentation. I want to give an introduction to the buffered input stream. I want to talk about the inner workings on the buffered input stream. I want to talk about the buffered input stream class declaration, the buffered input stream constructors, the buffered input stream methods, and the buffered input stream examples, some actual code to see how to use it. So quick introduction, a buffered input stream in Java is a concrete subclass of the filter input stream. And so the filtered input stream is kind of common. There's a couple different concrete subclasses we'll look at. And so I've chosen not to really do too deep of an examination of the filter input stream. Just know that the purpose of a filter input stream is you can take some other input stream and pass it into a filtered input stream so that you can add more features on top of that input stream. So it allows you to wrap or buffer that stream with, well, in this instance, filtered input stream allows you to wrap it and give it better functionality or more options than what you would normally get on an input stream. So in this instance, a buffered input stream is a subclass of the filter input stream, and it wraps an input stream with a buffered stream that makes read operations on the stream much more efficient and much faster, because it gives us memory that we can use that we don't have with a normal input stream. So in simple words, it adds buffering capabilities to an input stream and that stores the data in bytes temporarily in a memory buffer by reading from the stream. So buffered input stream is used to speed up the input by reducing the number of disk checks or file reads by adding that additional layer of functionality around the underlying stream. So for example, the file input stream and file output stream, the ones we had just looked at in the last presentations in Java, are unbuffered. And that means that each time we want to either do a read or write request, it has to be handled directly by the operating system. So it makes the program less efficient, because for every read or write request, we have to actually access a disk or a file, and that ends up wasting a lot of time, especially if you're writing a lot or reading a lot of data. So on the other hand, if we have a buffer input data from a file by wrapping the file input stream into a buffered input stream, well, then the buffered input stream will actually store that data from that input source into a temporary block of buffered memory. So instead of having to request the OS to do a read every time you need data, it's preloaded into our buffer, and we can just access it from within our application. And so that then the data is sent individually to the program from the buffer, and the buffer input stream in the Java makes the file operations much more efficient and faster. So we kind of looked at the base cases previously, but consider using this to kind of speed up your operations. And so just to give you a figure of what the inner workings of a buffered input stream might look like, here you have your disk where your file would be at, say, for instance. And so you'd have a block of data that gets loaded into the buffered input stream. And then the buffered input stream would then provide, every time we call those read methods on the input stream, it'll then just give us the data that's prefetched into the buffered input stream. And so the buffered input stream is a buffer internally between the program and the source. And during the read operation, the whole block of data in bytes is read from the disk and temporarily stored in the internal buffer in the memory all at once. So the data is then transferred or read individually to the program from the buffer as we requested, based off of the methods defined in the stream. So the key points about buffered input stream, in Java at least, is that when the input data from the stream are skipped or read, the buffered stream automatically refills the data from the input stream each time. So when a buffered input stream object is created, a buffer array is created internally. Now, a buffer doesn't necessarily hold all the bytes from a file. Like if the file is very large, it'll fill up to a certain amount, and as you read it, it'll constantly keep refilling, like a bucket of water. So there is a limit, but as you use it, it'll constantly refill. So buffers can be constructed by using a buffered input stream and a buffered output stream classes. So let's take a look at the class declaration for the buffered input stream. The buffered input stream class is derived from the class filter input stream, which has input stream as a base class. And so the buffered input stream implements closable and auto-closable interfaces. Super important that we can close any stream. The general declaration of the buffered input stream looks like this. So it's a concrete class, public class buffered input stream. It's a subclass of filter input stream, which for the most part, we understand the mechanism of the filter input stream is just a stream. It's a stream that takes in as an argument another stream, because it adds functionality to that stream. We're going to really pay more attention to the subclasses of filter input stream, because filter input stream doesn't really provide any methods in and of itself. It's just kind of like a parent class for all these other kinds of input streams that add in these kind of unique methods like buffers, or we'll look at the data input stream, which is also a type of filter input stream that allows us to read our data or write our data in primitive data types that Java can parse. So it's not a byte, or that it's not a character. And so these buffered input streams have been in Java since version 1, right? It's inside the java.io.bufferedInputStream package. Okay, let's look at some of the constructors. So to wrap an input stream, the buffered input stream class defines two constructors that are as follows. So we have buffered input stream, and a buffered input stream requires an input stream. So again, we're building the buffer around a pre-existing input stream. So again, this constructor creates a buffered input stream object that buffers an input stream specified by the input stream. It uses a default buffer size of 8,192 bytes. And so the general syntax for our buffered input stream would look like this. So a new file input stream, and then we can either pass it in a string that is the file path. Well, I'm sorry. The first thing we would do is create a file input stream. So we need a original input stream. So here we'll use a file input stream. We'll pass in a string that is the file path. That gives us a file input stream reference. Then we can use that file input stream reference and build around that a buffer input stream, right? So we'll then use the constructor for buffer input stream on the file input stream, and then we will do all of our operations on this buffered input stream reference, because that's going to give us all these new methods, and it's going to give us the more efficient capability of reading from that file. Okay, there's a second constructor, right, where we can go ahead and not only pass in an input stream object, but also a size in the form of an integer where we can specify what the size of the buffer is. So if you need a larger buffer than the default size, you can easily pass that value in. So the general syntax here is you would create a new buffer input stream, you'd pass in your pre-existing input stream, and then the size in the form of an integer to create your new buffer input stream instance. And so now you can perform all the same IO operations through the buffered stream. And at last, you want to close the buffered stream after you're done doing all your IO operations with the close method. So closing the buffered stream will automatically close the underlining file stream as well. So you don't have to close them individually. Once you've nested your original stream inside of your buffered stream, you only have to close the buffered stream, and then it manages closing the internal stream that is kind of managing over. And of course, if you don't close it, then you might get an IO exception that gets thrown, and you might have corrupted data on the file. So always close when you're done using. So let's look at some of the methods. So buffered input stream class does not define any new methods, right? All the methods in buffered input stream are inherited from the input stream class, but some important methods that we should talk about, that we should always go over. They have an available method. So this method returns the number of available bytes from the input stream without being blocked. We have a read method. This method reads the next byte of data from the buffered input stream, right? It returns an integer. We have a read, and then we can pass in a byte array. So it reads the bytes from the buffered input stream and stores them in the specified array that we pass in as this parameter. We also have a read method where we can pass in a byte array, and then we can give an offset as an integer value that we'll call n, and then we can have the number of bytes we want to read, which will be m. And so it reads up to m bytes of data from the input stream and stores it into an array of bytes starting from the nth byte. We have the close method. That method closes the buffered input stream and releases any of the system resources associated with it. We have a reset method. This repositions the buffered input stream to the last marked position. We have a skip where we can pass in effectively a long integer value. And so this method skips over and discards X bytes of data from the buffered input stream. We have a mark where we can pass in a mark method that we can pass in what the read limit is in the form of an integer. And so this method marks the current position in the buffered input stream on where we're at. And then we can check to see if mark is supported. That returns back a Boolean value and it tests whether the buffered input stream supports the mark and rest methods. So almost all the methods, recall that these are all the methods we talked about are checked exceptions, which means that we either have to throw an IO exception when we use them in one of our own methods, or we have to perform our IO operations inside of a try-catch block where we attempt to catch an IO exception. So always keep that in mind when you use any of these classes. That's part of the IO package. So let's take a look at some code. Let's take a look at the first example where we will try to read some data or text from our myfile.txt file using the buffered input stream. And so here is the source code, but I'm going to jump right over here to our. So I'm going to go to buffered input stream. I'm going to go tester 1. So I'm going to go ahead and I'm going to import our buffered input stream class from Java.io, but I'm also going to have to import our file input stream class from Java.io because we require an input stream to build a buffered input stream. I'm going to create a new class so that I can create a main method so that we can actually create code. I'm going to create this try block so I can perform our IO operations. And so I'm going to also have this catch block in case we throw an IO exception. And I'll just go ahead and log that to the console if it were to happen. So the first code that we're actually going to do is we're going to create a file input stream object, and we're going to pass it in a reference to the myfile.txt file that I have in here. So if I were to open this up, this is a file that we have already exists in our system that says, welcome to Computer Science. So I'm going to attach the file input stream to that file, and then I'm going to save a reference of it under the name FIS, short for file input stream. Then I'm going to create a new buffered input stream, and I'm going to pass that. I'm going to pass to the constructor a reference to the file input stream, and we're going to build the buffered input stream on top of that, which we will now call BIS. And then we're just going to set up so we can read the data from our input stream. So I'm going to create a loop control variable that I'll call I. I'll just set it to 0. It's going to look for an integer. Recall that as we just use the default read, that it returns a byte at a time. So I'll go ahead and save that byte into I, and then I'll evaluate inside my loop control evaluation here. If the resulting value of I is not equal to -1, recall that with the read method, if we get a -1 value, that means we've hit the end of file. So there's no more content to read. So long as it's not -1, we will cast that integer value into a character, save that into a character variable, and then we'll just print that out to our display. Then when we're done, we'll close our BIS. We shouldn't have to do this. Right? That should be managed for us. So let's go ahead and run this code. And so here we can see, yeah, we went ahead and opened up that and displayed into our console, welcome to Computer Science. Okay, let's look at another example where we're going to actually try to get the number of available bytes in the input stream. So for this purpose, we're going to use the available method. So let's take a look at the source code. And in fact, I don't want to look at the source code on the slide, even though I make it available there. I prefer to look at this source code here in IntelliJ, so we can go ahead and actually execute it. So again, in order to be able to make this application, I not only have to import a buffered input stream, but I also require something like a file input stream that I pass into my buffered input stream. I'm going to create a class here that has a main method, so we can actually create an application that runs. I'm going to create a try block because I need all my IO operations to be nested in a try, which means I also have to have a catch in case an exception occurs. Here, I'm going to create a new file input stream, and I'm going to read that same file. I'm going to give it a string of the file path of my file.txt. That's the same one we used in the prior example, the one that says welcome to Computer Science. I'm going to save a reference to my file input stream here under this. And then I'm going to create a new instance of a buffered input stream, right? I'm going to invoke the constructor. I'm going to pass it that file input stream reference so that we can actually create a buffered input stream. I'll call it BIS. Here, I'm going to start by finding out what are the available bytes inside of my input stream. Then I'm going to call read 3 times, which will read 3 bytes from my input stream. Then I'm going to go ahead and call the available bytes again. Actually, let's run this so we can see the first time we go and read what's available, we see that there were 32 bytes. And the second time after we do 3 reads is now going to be 29. So we've reduced it by 3 bytes, which makes sense because a read is a byte at a time. And then after we do that, we're just going to go ahead and close. And then for my final example for a buffered input stream, I just want to show you the skip method where we can go ahead and discard and skip a specified number of bytes from our input stream. And so this is going to be our source code. Let's actually go here and open it up inside of IntelliJ. And so here I'm going to import buffered input stream, and I'm also going to import file input stream. I'm going to create a new class, a tester class with a main method so we can actually do this code. I'm going to put all of my IO operations into this try catch block, which means I'm going to have a catch in case an exception does occur. Here, I'm going to create a new file input stream. I'm going to pass it in the string of that my file.txt that we already have, the same one I've been using. And I'll call this file input stream this. And then I'm going to create that new buffered input stream that requires that file input stream to build on top of, and I'll call this BIS. And so on our buffered input stream, I'm going to say, hey, skip 5 bytes from the buffered input stream. And actually, let's run this so we can see what's going to happen when I do that. And so here we're going to skip 5 bytes, and then we're going to set up. So we're going to start reading from it. So I'm going to create a loop control variable here. I'm just going to start it at 0. Then I'm going to override it immediately during the evaluation. So for BIS, I'm going to read the first byte. I'm going to set that to my loop control variable I. And so long as I is not equal to -1, because that represents an end of file state, then I will cast the integer into a character and just print it out. And so notice when we do that, we've actually skipped the first 5 bytes inside of our text file, right? WELCO. And so what we start writing is going to be the M. So we get me to Computer Science. And then after we're done reading the contents of our input stream, we'll go ahead and close it. Excellent. And that's everything I kind of want to talk about with our file input, our buffered input stream. And so, is there any questions related to the buffered input stream?